Let me give you one example, right? If we being asked to find V3 for the following circuit, where is our V3? Which is here. But you must always remember, as I said to you, number one, you need to observe. If you observe this circuit, you see you have your current source, you have your voltage source over here, you have your current source over here. And you must remember, your 5 ampere over here is actually creating super mesh situation. Why? Because your 5 ampere being shared with this mesh as well as this mesh. Right? Is that clear? Now, to solve this question, what we can do, for example, since we are aware this is your super mesh condition, we can still remain to put this is I1, loop 1, right? This is loop 2, this is loop 3. But you must remember, since we are having super mesh here, we need another super mesh over here. You see, super mesh. Super means it very overall. So it covers both two different meshes. So it is not that difficult. Why? Because it is very straightforward. Since your I1 is here, so what you can write is very straightforward. Loop I1 equal to 2 ampere, because your I1 is in the same direction with this 2 ampere. Right? And what is your support equation? Because you need to solve by preparing support equation as well as later super mesh equation. So you just need to, for example, I figure out this junction. So from here, from this junction, right, I redraw over here. So this is your 5 ampere, which is here. This is your I2 and this is your I3. So you must remember this is applying KCL. Current entering equal to current leaving. So what I can put here, I2, right? I2, current entering, 5 ampere also current entering, equal to current leaving, which is your I3. That's why you can have equation 2. But now, what is actually your super mesh equation? You must remember your super mesh, they must cover, right, this super mesh, the whole mesh. Okay. What you can write over here, okay, for I2 minus I1, okay, over here, right, this is number 1, 4 ohm, right, and your current for your 4 ohm is I2 minus I1. That's why we are having here 4I2 minus I1, plus, this is 1 ohm, right, okay, what are the currents flowing? So you have I3 should be and I1, that's why you have I3 minus I1. Okay, for here, you just have only I3. That's why plus 3I3. Okay, and it flowing through here until here. That's why minus 38. So what you need to do is only to rewrite and rearrange, and finally you can get 3. So once you have 1 as well as 2, right, then you substitute into 3. Okay, so you substitute into this third equation. So you can get your I2 as well as your I3. Okay. Since the question asks what is actually the value of V3 over here. So you must remember you need to redraw something like this to make it very, very clear what are the current flowing. For example, this is your voltage drop in the 4 ohm resistor. You have current flowing I2 in this direction and I1 in this direction. You must remember V3 equal to IR. Right, so what is your I? So I2 entering positive terminal minus I1 in this way multiplied with 4. So finally, what you can get V3 equal to 6 ohm.